Ahoy, me mateys! We're going to do a pirate problem in honor of International Talk Like a Pirate Day. So we are going to do a kinematics problem with two objects, and it's going to take place on a pirate ship, because it's International Talk Like a Pirate Day soon. So our problem is Polly the Parrot. Polly the Parrot is flying in a straight line at 1.5 meters per second when she sees that Billy Spanky, great pirate name, Billy Spanky has dropped some of his bread. It takes her 0.15 seconds to react, but then she accelerates at a rate of 0.2 meters per second squared for 1 second and grabs the bread. How far was she from the bread when the pirate dropped it? Okay, so we have pirate kinematics. Our first point of order is always draw a picture. And so we've got a pirate. He'll be sitting on a barrel. There's a barrel. And he drops a piece of bread. Bloop. And oh boy, parrot, huh? That's a parrot. Yeah, that's a parrot. So she's going to start here. So that's Polly. Really. And she is going to, she's flying in a straight line at 1.5 meters per second. So she's going to take a little bit of time to react. And then she's going to accelerate until she gets the bread. Alright, so there's my picture. I'm going to choose as my origin where she starts. So I'm going to choose this right here as my x equals 0. And I'm going to use my standard coordinate system. To the right is positive. Okay, so what is the question? How far was she from the bread when he dropped it? Okay. I'm going to realize here that we're reacting in 0.15 seconds. So that's a typical reaction time, is about 1/10 of a second. So while the parrot is reacting, she's moving at a constant velocity, the constant velocity she had when she started. So she sees it, takes her a little bit of time to react, and that's constant velocity motion. And then we have accelerating motion. Our kinematics equations only work for constant acceleration motion. Here we have acceleration of 0. Here we have acceleration of 0.2 meters per second. We can't do this in one step because we have different accelerations in this whole process. So I need to treat this as a two-phase problem. So 2 phases. I'm going to do the reaction phase and then I'm going to do the acceleration phase. So let's see what we know during these 2 steps. All right, my 6 kinematics variables, V initial, V final, A and T, and then the same 6 during acceleration phase. Okay, so what do we know? What can we fill in about these 2 phases? Okay, we know x initial is 0 because I chose that as my origin. And we don't know how far she goes in the reaction time. We know she's starting at 1.5 meters per second. And since she's moving at constant velocity, that's her ending velocity as well. And if we have constant velocity, we're not changing velocity, we have no acceleration. Do we know the time? Yes, we were given a reaction time of 0.15 seconds. Okay, so that's our first reaction time. So that's this little bit here. Now, what do we know about the acceleration time? Do we know where she starts her acceleration time? No, that's here. It's not x initial equals 0 because that's way back here. Now my initial is just here, my final's here. We do want to know where she ends up because how far was she when he dropped the bread? So we want to know what this total distance is. We know she's accelerating at a rate of 0.2 meters per second squared, and she's going to be speeding up in a positive direction, so that's positive. We don't know how much, nope, she does. We know she does that for 1 second. Do we know how fast she's going at the end? No. How fast is she going at the beginning? Yes, I do know this because this leads right into that. So her final velocity in the reaction phase is the same as her initial velocity in the acceleration phase. So I know that is 0.15 meters per second. Similarly, I know that wherever she ends up in the reaction phase is where she starts her acceleration phase. So if I could get this, I could get this. Maybe I don't need it. All right, so we want to know what? We want to know x final. All right, so of this, I got to figure out how to get x final. Let's see, x final, I usually start with this one to see if I can solve it with the long one. And, you know, it's a good one to start with because it has x final right there. So I want to know x final. Shoot, don't know this. V initial, I do know. I know time, I know 1/2, I know a, I know t squared. Okay, so I can't use this because I need to know where we start. Okay. How about one of the other ones? V final equals V initial plus AT. There's no x in that. The third one, the squared one, maybe that one will work. Plus 2A delta x. Okay, so V final, don't know that. I do know that. No, and I don't know that. Okay, so you stop and you say, what do I do? Well, this one has two unknowns in it. I don't know x initial or x final, and I don't know V final. So I'm going to guess this one is not helpful at all. Let's get rid of that one because I think that's not going to be a good choice. Is there some way that we could make this one work? We know everything here except our initial position. But what I just said here is our initial position for acceleration is the same as our final position for the reaction time. So I can get this, I think, from the reaction side. So let's see if I can do that. Okay, and I need to know, really, so I'm looking for this now. On the reaction side, I'm looking for x final. If I start with the same one, let's see if this will get it to me. V initial t. Okay, so I'm looking for x final. I know x initial is 0. I know v initial. I know my time. I know 1/2. A is 0, so that whole term drops out. Great, I can do it. Could I also use one of the other equations? Could I use that squared one, which is the other one that has some x's in it? V final, oh, bad one, try again, equals V initial squared plus 2A delta x. I know V final, I know V initial, I know 2, I know A, and I'm looking for my change in position. So you might start with that one if you wanted to, and you'd say, great, I know this. And then I would look and I would say, acceleration is 0. Which tells me that V final squared equals V initial squared. Oh look, these two are the same. So it's not wrong. We can absolutely use the squared equation. It just doesn't get us anything. So I think I'm stuck with using this one. All right, so what do we need? No, we have everything. I think we've got everything. X final is what I'm looking for. That's 0, so V initial, 1.5, times our time, 0.15. And that's 0. Okay, so I do that, and I should get what? 0.225. Yeah. 0.225 meters. Is that reasonable? So 0.225 meters is 22.5 centimeters. So it's less than a foot. That's like this much. Is that a reasonable time or reasonable distance for the parrot to move in about a 1/6 of a second? I would say so. She's not moving very fast, 1.5 meters per second. So I think that's a reasonable answer. So now I know what my x final is for this step. I can put that in 0.225 meters, which means I now know my x initial for the acceleration step. So she's 22 centimeters from start when she starts accelerating. Now, do I have everything here? I have everything because I now know my x initial. I can just solve this one for my x final. All right, x final equals x initial. There we go, 0.225. Do I have any zeros? Oh, I don't. Okay. Plus v initial, 1.5, times time, 1 second, plus 1/2 times my acceleration, which is 0.2, times time squared, 1 squared. Okay, so x final equals all of this. So if you do that math, you should come out with, what did I come out with? 1.8 meters. So x final is 1.8 meters. And before you just walk away, always stop and say, did I answer the question? Is it reasonable? What was the question? How far was she from the bread when the pirate dropped the bread? So we now know that x final, this right here, is 1.8 meters from our origin. So I would say we know the answer. Yeah, the distance she traveled, total distance, is 1.8 meters, so that's how far she was from the bread when he dropped it. So we did answer it. Is it reasonable? 1.8 meters, that's about 6 feet. So is 6 feet reasonable distance for her to see a piece of bread, react, and then speed up until she catches it? Absolutely. I think she could do that. No problem. So I think we've got this one totally done. Polly manages to get her piece of bread. Not a cracker, but you know, they wouldn't have had crackers on pirate ships, so they would have had some bread at least. All right, we've got this one taken care of. So I hope this one made sense, and you can see why we had to do two different steps, because we had two different accelerations. Can't do the same thing if our accelerations are different. So it's just two phases, and we have these phases connected to each other this way, and from that, it was pretty straightforward. All right, good job.